Hey everybody. So continuing our discussion on friction, when it came to threads and bearings, I trusted that you know how to plug numbers into a formula. So for this application called belt friction, similar, there's just a formula to plug numbers, but I think it will take some explanation as to how to get the numbers in there and what the directions mean. So let's start off with saying belt friction. It's not like there's a pulley and then this is a bearing. This is different. Imagine if the bearing kind of completely rusted and now it no longer rotates. So we have a fixed cylinder. So this is a fixed cylinder. For example, here, like you wrap a rope around this wooden post. The post is not rotating. It's fixed. And just dragging the rope around this surface. Like here, imagine this is fixed and you're just dragging the rope, maybe this way, over this curved cylinder. So by doing that, the force on this side, the tension, will be different from the tension on this side. Okay, so first order of business, which is more? Now imagine you're pulling the rope this way with some velocity. So then there's going to be kinetic friction. Which way? Opposing your motion. Say like this. Kinetic friction, opposing your motion. So if that's the case, which side is more? Right? There's tension on this side, tension on this side, but see how the kinetic friction is in the direction of this? So that means this side, T2, has to be more than T1, right? If you went the other way, so you pull the rope this way, then friction would be opposing your motion this way. So then this side would have to be more than this side, right? Because it's like you have two of these going counterclockwise and then only this one going clockwise. So how does it relate to our formula here? Which side is more, T2 or T1? And the formula goes, T2 is T1 e to the something, right? And that's the coefficient of friction and some angle, this angle right here. I'll explain that in a minute. Now, this coefficient of friction is going to be a positive number. This angle right here, positive number. E to the anything positive, I guarantee you, is greater than 1, because e to the 0 is 1. If you go like e to the 0.0001, that's greater than 1. So if this is greater than 1, I guarantee you this is more, T2, and T1 is less. Okay, so remember that for this formula, right? This quantity right here is for sure greater than 1, which means this is more, this is less. T2 is more, T1 is less. Okay, so remember that forever as far as the application of the formula. And then let's talk about that, which one is more, which one is less example. Imagine there's this block that is 100 pounds. And let's say you're trying to lower it. So you're lowering the block. So the velocity is this way. Let's say a constant velocity. That means there's going to be kinetic friction kind of opposing your motion like this. Opposing your motion. So now, if over here is 100 pounds, what is over here? More or less? Just have to think about it, right? It's like 100 pounds this way. And then look here. I'm just going to make up a number just for an example. So this side, for sure, has to be less, right? I'll just make up a number, like 90 pounds, right? Because look, the friction is helping you kind of in this direction. So this side is more, this side is less. And then if over here is 90 pounds, look, there's friction opposing that motion. So let's say over here is more or less. It has to be less. I'll just make up a number. 80 pounds. Right, so this is less than this. I'm sorry, yeah. And then this is less than this. So if you're lowering the block, you only need to apply, let's say, 80 pounds as you're lowering it, because the friction is kind of helping you support the block. And then if you just want to hold it static, you could apply just, let's see, and then we switch these to static, and then just make up, like, say this is a 80 pounds over here and 60 pounds over here. Just made up some numbers, right? So it takes less force to hold it steady, stationary. But now let's say you want to lift the block. So you want to raise the block, the 100-pound block. So this is 100 pounds. If you're trying to raise it, then the velocity is this way. Let's say constant velocity. So friction is opposing your motion this way for each of these fixed cylinders. So that means, let's say if this is 100 pounds, this side has to be more. Right? I'll just make up a number, 110 pounds. More. And if this is 110 pounds, this side over here has to be more. So let's say 120 pounds. Right? So now it takes more force to lift it because of the friction opposing your motion. Okay, so I hope that makes sense. Now let's talk about the nuance of this angle right here. So here's a different picture. Okay, so based on this picture, this angle here, beta, the formula is T2 is T1 e to the whatever coefficient of friction, static or kinetic, and then this angle beta in radians. In radians. Okay, but then how do you get this angle? Look at over here. So let's say you have a pulley that is just like this. Like this is horizontal, this is vertical. The angle here is like this. That's beta, right there. So in this example, that would be 90 degrees, and then you convert to radians, like pi over 2 radians. But now, let's say, let me draw it a little bigger. Instead of just horizontal and vertical, what if it's like a little bit this way? So let's say this is 10 degrees. So here to here, here to here, right? Before, this was 90 degrees. But now we have this little bit of extra over here. 10 degrees over here, 90 degrees over here. Right, so now this angle here would be 100 degrees, and then convert that to radians. And then now let's say the rope wraps around an extra, like over here. Over here, 10 degrees. So what does that do? Now, like this, see right here? That's an extra 10 degrees. And let's say if over here, like that's 20 degrees, then this would be 20 degrees. Or how about if the rope were more like this, like this. And then let's say right here is 10 degrees. What's that gonna do? Perpendicular to that is like this. So this here would be 10 degrees, which means this over here is kind of the leftovers, 90 minus 10, 80. So then the angle beta for this particular example would be right here, 100 degrees. Okay, let's try this example right here. What is it? So there's that fixed cylinder. I'll just draw it over here. Okay, and then let me draw maybe over here. Here to here is how much? 45, right? So that's like here to here, this is 45. So then perpendicular to that is right here is 45, right? Now let's look over here. See right here? Right here? To here. This is 30 degrees. So then perpendicular would be which way? This right here is 30 degrees. Which means here to here is kind of the leftovers. 90 minus 30, 60. So what is the total angle beta for this example right here? Here, like this. 45 plus 60. Right, 105 degrees, and then you convert that to radians. And that would be beta. Okay, so maybe you might want to review this again. It's a little bit tricky. It's not meant to be tricky, but it can be. Okay, so if you have any questions, just post to the forum, and I'll see you in the next video.